For those who think that ChatOps is just for cute GIFs, think again. Today I'm going to talk about ChatOps at Shopify, and especially how we use it for all kinds of commands, from adding new collaborators to GitHub repos, to managing incident, to even failing over to another data center. I really want you to leave this talk with new ideas about how you can invite bots in your day-to-day operations. And I also really want you to realize that ChatOps can be truly powerful and change the way you work. My name is Daniella Niyonkuru, and I am a production engineer at Shopify. For those who are wondering, no, Shopify is not a typo of Spotify. Shopify is actually a Canadian-based tech company, and it enables entrepreneurs to sell anything to anyone and anywhere. So if you've ever bought items from an online store, chances are that you've already interacted with a Shopify product. We also offer solutions for those who sell in person. So our team, production engineering in particular, is responsible of delivering speed and reliability to our merchants and also to our developers. So here are some numbers just to give you an idea of what scale we operate on. We power more than 500,000 merchants, and we also have more than 1,200K developers to enable. We get more than 1 billion requests every day, and we have had more than 40 billion that transited through our platform. So when Shopify is down, it's quite a huge deal. The other thing to know is that we are mainly a Ruby on Rails application. And then the other interesting fact is that we deploy Shopify more than 40 times a day. So when I started at Shopify, the very first project that I worked on was actually on ChatOps. So it's a topic that's near and dear to me. So what is ChatOps about, right? What is it anyways? Well, ChatOps is all about conversation-driven collaboration. It's about bringing the work you are already doing into the conversation you're having. So basically, you use group chat tools to go beyond basic conversation and actually bring infrastructure tools and all the third-party services into the discussion that you are having. And this can be a huge time saver. So usually the setup looks like this. You have teams that have their conversation in a group chat app. And then this chat app is usually linked to infrastructure and third-party services through third-party integrations or chatbots. But usually the way to go when you really want to unleash the full potential of ChatOps is to use a chatbot, just because it allows you to customize commands to your own team needs. And the communication between the chatbot and the chat app is usually done via webhooks or RESTful endpoints. So one of the questions that you may have at this point is like, OK, that sounds cool. So how do I choose a chatbot, right? Do I build one from scratch, or do I actually use an off-the-shelf one and then customize it? Well, off-the-shelf ones have the benefit of already being pluggable into common chat services. So when you get started, it's actually easy to add your own commands. In our case, we started with GitHub's UBot, which is a Node.js application that's extensible through CoffeeScript or JavaScript. But later on, we decided to move on to Lita, and now our Spy, which is our chatbot, is based on Lita. So our ChatOps architecture looks like this at Shopify. We use Slack as our chat app, and then Slack is connected to our Spy, which is the chatbot that we use. Spy is a Ruby application that was built based on the Lita framework, and then Spy is actually connected to our infrastructure, our internal tools, and dozens of other APIs, namely GitHub, PagerDuty, BuildKite, New Relic, et cetera, et cetera. So it's really easy to add new commands to Spy. So let's say we want to add a very basic command called findAnswer. And then I want this command to actually give me the answer to life, universe, and everything, which is what we are always looking for, right? So all we have to do is to define a subclass handler of Spy, and then actually say what the callback is going to do. So here I define a findAnswer method that will reply with 42. And then the other interesting thing to notice here is that we have a brief description of the command in the help, and that will actually help all the future users to know what this command is for. So we have more complicated commands, of course, and now I'm going to talk about those. So I'm going to talk about the use cases and operations for which we use ChatOps. And so I'll divide this in 3 categories. I'll start with the infrastructure ones, then I'll talk about incident management, and finally I'll touch upon the ones that we use for developer onboarding. So let's start with infrastructure. So this is a very rough overview of what our infrastructure looks like. We have routers that are connected to the wired internet, and these routers will actually forward traffic to our load balancers. Load balancers will then send requests to web servers or app servers and job servers for batch processing work. And then at the very bottom, we actually have our databases that store the data of our customers, right? And then the other thing that you can notice here is that at the very top, we have a CDN layer or an edge cache layer. CDN stands for Content Delivery Network. So this is where we actually store our static data, like images, so that they are closer to the end consumer. And the other thing that you will notice is that most of the things that you will see here are in multiple copies or replications, because we always build at Shopify for having like multiple backups and also being able to recover from multiple catastrophic data center failures. We currently have 4 regions that we can fail over to. So the awesome thing about this actually architecture is that we have a spy command to interact with each one of those components. So I'll talk about some of the spy commands that we use for every one of those. Let's start with the CDN. CDN stands for Content Delivery Networks. As I said before, this is what we use to store images. And then one of the things that we can do with spy is actually show the traffic that each one of those active endpoints is actually getting. So spy CDN show traffic will actually show how much traffic every endpoint is getting. And then the other thing that we can do is that we can actually rebalance traffic and then send it to another region. So we can specify which region to send traffic. It could be either US East, US West, or we can actually decide to split it among all those regions. So in this case, spy CDN backend, all in the example, is splitting traffic among all the backends that we have. So that's why we have 25% for each one of those. The next component that we're going to look at is our load balancers. So one of the commands that's really useful is spy nginx status. This will show all the connections and the upstream's health. So if any peer is up or down, it will actually show that up in the message that spies print. And then the other thing that you have to know is that we have nginx load balancers with OpenResty. So this allows us to do a lot of things because we get the power of scriptable load balancers with Lua. So with Lua, we can do checkout throttling, we can do edge cache, we can also do some automatic bot squashing, and this is also all enabled through Spy. So one of the things that we usually want to do is profile this Lua code that runs in our load balancers. And this is a pretty handy command to do that. We can just run spy profile nginx Lua, and then specify the mode, and this will actually print out a flame graph and show where the time is spent for each call. Good. So now let's look at the web servers or application servers. The very first command that I'm showing here is spy revisions. This will show all the revisions that are currently running in production. And this is especially helpful when we have like flapping deploys, and then we get multiple versions running at the same time. This will actually show which revisions are actually running in production. And then the other thing that we can actually do is to specify a type so that we can see which nodes are in rotation and which ones are out of rotation. The next command is one of my favorite. It's called spy shops. This will actually print the top 10 shops that are generating the most traffic. And it will actually show what shard they are in. So when there is a flash sale or something like that, we can actually see how much traffic they are getting. The other command is similar to the one that I showed for nginx, and then it allows us to profile Shopify itself. And then we can filter this by DC, by shop, and actually customize the duration or what mode we actually want to profile this in. So now the next component is actually job servers. We can actually see what work we have pending for each queue with the spy rescue command. This can filter per DC, per queue, or anything similar. So for instance, here, spy rescue DC Ash is actually showing all the jobs that we have waiting in the queues for the Ashburn data center. The next command is spy job working. So now if we want to know what workers are actually running, we can run that command, filter by DC, and actually get to know what they are working on. The next components are the databases. So our databases are set up in active-passive mode, and when we want to retrieve that information, we can just run a spy shard with the ID of the database, and then we get to see which instance is set to be the writer, which ones are the readers, and which one is the standby. So the readers here are in yellow, the writer is in blue, and then the standby one is shown in gray. Now, if we want to know how many database calls each shard is getting, we can also use spy and just run spy shard load. And so this actually helps us in a lot of cases to know if we're getting like a lot of traffic for a specific shard or what's actually going on during incidents. Good. So I've showed you some of the commands that we use to query our components. So now, the other thing that we usually want to do is to be able to manage this infrastructure and, for instance, recover if there is any catastrophic data center failure, right? And the way we do this, one of the commands that Spy gave us is spy file over Shopify pod. Before I actually talk a little bit more into details and explain how this works, I want to give you a little bit more context about what a pod is. And the pod that I'm talking about here is different from the Kubernetes one. We define a pod as a set of, as an isolated set of shops. So for us, a pod is basically an independent Shopify. And if we put this in the context of the overview that I gave earlier, we have something that looks like that. So we have shared load balancers, and then we also have shared workers, and then we have this set of isolated pods. So the benefit of having shared workers here is that when a pod is getting more traffic or needs to actually do more work than the others, so for instance, if there is a flash sale, a pod can always go and use some of the shared workers if it needs more capacity, versus actually having all dedicated workers and having to spin them off on a need basis. So this is way faster. And if we look at what a pod is internally, well, it has a set of dedicated workers, and then it also has its own data stores. So every pod has its own Redis, it has its own Memcache, and it also has its own MySQL. And you might think of this as being a shard in your case, but really what a shard is for us is just the isolation on the relational database level, which is the MySQL one. So for us, a pod is much more than a shard. It's actually having the dedicated workers, Redis, and Memcache. And the other thing that you can notice here is that we have active and passive pod. So a pod will only be active in one region at a time. Here, pod 5 is passive in this region, which means that it's probably active in another region. So one of the commands that we have actually shows us which pods are active in which region. So spy pods will actually show us for each of the regions that we have. So the Ashburn data center, the Chai data center, and all the other ones, which pods are active in each one of those regions. And so one question that you might have is, OK, that looks pretty cool, but what if you need to move a pod, right? What if I want to put a pod in another region? How do you go from this to this? How do I get all the pods that were in Chai 2 to go to Ash? So let's say we need to perform an emergency data center evacuation. How do we do that? And can Spy help with that? The answer is yes. We can do that with the spy failover command. And with spy failover Shopify pod to location, we can actually specify one or multiple pods and then fail them over to another location. So here, for instance, you have Nico, who's failing over pod 21 to cloud 2. And one interesting thing to note here is that this is a restricted command. we don't want everyone at Shopify to do failovers because it's quite a complex operation. So you need to authenticate yourself first. So we use Google Authentication for that. So before performing a failover, Nico had to authenticate himself, and then only after that the failover can be actually done. And then the other thing that Spy is going to give you is a dashboard to look at if there is like anything that happens in the meantime or any. So how does this actually work? How do we fail over a pod from one location to another? The very first thing that we're going to do is to retrieve what is the current data center, and we do that by actually going to pull our service discovery component. And once we do that, the next thing that we're going to do is to actually pose request in the source data center. So the way we do this is that we pose requests at the load balancer layer so that our customers won't get any 500. And this is actually useful because if you imagine yourself in the scenario of a customer who's actually checking out and you've just like put your credit card number and you just get an error, it's really a bad customer experience, right? And what we do instead is that we make you wait a little bit, but you don't lose your information. And the way we do this is that we pose our request at the load balancer level, we put you in a queue, and then you're going to stay there while we're performing the failover. And so once we've posed the request, what we're going to do is actually update the service discovery component to have the new target data center as the one for that pod. Once that's done, we're going to actually set the MySQL server that was the writer to be read-only. And then we're going to wait for the replication to catch up in the target data center. Once all of that has catched up, we're going to set the standby writer in the other data center to be the active one. And once everything is all good and good to go, what we're going to do is reload our load balancers, make sure all new requests can be routed to the correct data center. We're going to resume request, and then we're going to transfer all the jobs from the old data center to the new one. And usually all of this process takes less than a minute and a half to complete. So before we had this command, what we used to do is that we used to have a bunch of engineers come up very early in the morning when traffic was at its lowest. And then they had to go through this like long checklist and look at multiple monitors. And it actually required a lot of preparation. This is an example. This is a time where we had to perform an emergency failover. It was in the evening. It was at a coworker's house, and you can see that everybody was like glued at their computers. It wasn't really an awesome experience. But with the new spy failover command, it's become so simple that a child can actually do it. This is Mark. He's a coworker's son, and that was his face after performing a successful failover. So we can also do much more than that. So let's say we have servers that we want to test out on new branches. We can just use spy chef environment, specify what the new branch is, and then put that server on that branch. We can do canary deploys in the same way by using spy. We can also communicate with multiple third parties. We can actually do spy new relic and then the application to retrieve some metrics. Similarly, if we need any spy Datadog metric, we can actually get a summary by just using spy. So now I've explained to you how we deal with catastrophic data center failures. But how do we deal with incident management in general, and how does spy help? I'm going to start by a quick question first. Who's actually excited to go on call for incident management? Oh, you're awesome. How do you do that? When I'm usually on call for incident management, I'm like, fingers crossed, let nothing break. Like, I don't want to do this. But anyways. So one of the sweet things about being an SRE or a production engineer is that you get to be on rotation for incident management. So this means that you get to handle all kinds of disasters, right? Like this one, where checkout is down. By the way, this is one of the worst things that can happen, because if checkout is completely down, it means that none of our 500,000 merchants are actually being able to sell anything. And this is like a super burden for you. And so the reaction that you usually get is what Camilo said there. And so before being an IMOC, which is what the incident manager on-call role, before being an IMOC, you actually go through training where you learn what being an incident manager on-call is about. And what this is really, it resembles the incident commander that we have in the ICS system. So the role of an IMOC is to lead the incident response, not to fix production issues. So he has to push the incident through the detection, the correction, the reflection phases, and then make sure that the incident has actually been addressed correctly. And so we have this kind of incident funnel response. And so what happens usually is that something breaks, and then detection will follow. So an alert will go off, or somebody will notice and actually page the IMOC. And once the IMOC conducts a very first investigation and the incident is actually true, he will start the incident. Once he starts the incident, the very next thing to do is to communicate. So he has to communicate with people working on the issue, and he also has to communicate with people that are not working on the issue, like people who actually communicate with merchants. And then he has to also make sure that a proper fix is actually being actively worked on. Once the fix is found, the IMOC can then stop the incident, but this is not the end of it, right? He also has to document the service disruption and detail what actually happened. And once the documentation is over, he has to follow up on some investigation. Once that's concluded, a root cause analysis meeting is usually scheduled to go through the whys the incident actually happens. And usually what we get out of that meeting are action items. And once these action items have all been addressed, then the incident is resolved. So it's quite a long process. But usually, at the end of this process, an incident shouldn't happen again. Like the same incident shouldn't repeat itself. So what we're going to do is actually go together through this funnel and see how SPY helps with that. SPY has 3 sets of commands to actually help with those steps. And those are SPY page, SPY incident, and SPY status. So let's say something breaks, and somebody pages the IMOC. So anyone at Shopify can actually page the IMOC with this very brief command, SPY page IMOC, and then a very brief description of what's actually broken. So here the person is paging the IMOC saying, oh, order notifications are not going out. And then what the IMOC will do is that he will actually do some prior verification, and if this is actually true, he will start the incident with this command, SPY incident start me, order fraud analysis outage. And so this will do 3 things. SPY will do 3 things here. The first thing is that it will bind this incident to the war room channel. This is the channel where everybody will actually go to discuss about the incident itself. The second thing that it will do is that it will print a very brief description of what's happening, say who's the IMOC, and where everybody should go to actually have the discussion. And then the very third thing that it will do is to actually print out anything that was going on before. So if there was already a reported incident on the status page, it will actually print it out there. So now the incident has been bound to the war room. Everybody's in the war room. The next thing that the IMOC has to do is to communicate, right? But SPY does actually take some of the burden off the IMOC. So let's say I'm at Shopify. I don't know what's going on, but I want to actually find out if there is any incident. I can just type in SPY incident TLDR, and at any given moment, I will be able to know what incident is actually happening, who's the IMOC, who's the support response manager. This is the person who usually communicates with merchants, and then who are the people involved. The next thing that the IMOC has to do is to communicate with other teams. So SPY does help here too. So for instance, when the incident starts, instead of having the IMOC actually reach out to the person who's in charge of communicating with merchants, SPY will do this on behalf of the IMOC. So if the incident is started, SPY will send a message to the support response manager and be like, hey, there is this incident that's happening. Just so you know, if you get any merchants report, this is what's happening inside. And similarly, when the incident is stopped, SPY will also send a message to the person to let them know that the incident is over. And the other cool thing is, if you're an IMOC and you actually don't know who to page, and the incident has been ongoing for a while, SPY will actually start suggesting you who to talk to. So let's say this is a really high impact incident. Spy will be like, hey, have you thought about paging OSHIT? By the way, the OSHIT team is quite the OSHIT team. It actually pages everybody who's on call in production engineering. So this is really for a high impact incident. And then similarly, may also suggest you to talk to the social team so that they issue some social media updates. The other thing that's really awesome about this communication aspect is that you can actually contact anybody, any team, within the war room. So let's say you want to message a channel or you want to send a message to somebody else. You can just type in spy incident tell, the team, and then the message that you want to send them to. And then similarly, let's say you need help from somebody in data source. You can just page them from the war room by just typing spy page data source. So this allows the IMOC to not do a lot of context switching just because everything can be done from the war room. And so to really focus on what's happening in the war room. The other thing that's usually very important to do during an incident is to actually communicate about the actions that are happening. What is everybody doing in order to mitigate the incident, right? And so this is an example of where we had some card server network issues. So we have 2 regions mainly for card server, Oregon and Virginia. Virginia was having some issues and transactions were not going through. And what Darren did here is that he just rebalanced traffic right from the war room. He was like, okay, I'm just going to go with spy CS traffic 0 to 100, which means that he's directing all the traffic to Oregon. And then so all the customers that were having issues in Virginia should be now okay and good to go. And this is a huge time saver because you don't need to, again, switch context to do this. It's done right from the war room. It prevents duplication of efforts just because the actions can be done from there. And then you can also do some of the other actions that we saw earlier. You can do a failover from the war room. You can log production right from the war room. And then everybody sees that in real time. So now, the other thing that we usually need to do is updates to the status page, for instance. That can be done also right from the war room. So we can retrieve what the status page says at the moment with spy status. This will actually show you within the war room what you actually have on the status page. And you can also do updates in the same way without leaving the war room. The other thing that's usually helpful here is that if you want to acknowledge a pager, you can also just do spy pager IMOC and then resolve the incident that you have at that moment. So at this point, you might be like, oh, that's super cool. You have like kind of cool commands that help you out with being an IMOC, right? But how do you actually remember all the steps? How do you remember which commands to use? And how do you remember all those incident response steps, right? And how to go through them? Well, you don't have to. Spy will actually remind you. So let's say you are actually handling an incident, and then you forgot to update the status page. Spy will actually check if there has been any update to the status page. If there hasn't been any, it will actually send you a message and then remind you to update the status page. Same thing if the incident is over and you haven't updated the status page. Spy will be like, hey, I think you forgot to update the status page. And the other thing that's more amazing is Spy is not just there to remind you of things that you have to do. It's also there to take care of you. So if you have been handling an incident for more than an hour, it will actually reach out to the IMOC squad and let them know that you've been handling an incident for a really long time. And so usually you will see somebody pop in the war room channel and be like, hey, I heard you've been handling this incident for a while. Do you need help? So Spy does also prevent on-call fatigue in that way. Good. So let's say now we have shipped our fix and everything is fine. The next thing for the IMOC to do is to actually stop the incident. And this can be done with spy incident stop. So this will clear the topic of the war room channel. It will also, again, like print the summary of the status page. So what you have to do next is usually generate the service disruption report. So this used to be a pain, because we used to go through all the war room channel like discussions and actually try to get a timeline manually and put that in a report. But now it's become way more easier with Spy, because with Spy incident note, you can actually add a note to the service disruption report. So here, for instance, at the very top, we have Hormoz who's actually adding a note to the report. He's just saying, hey, this person is looking into the incident. And then the other awesome thing, let's say like somebody actually says something smart in the war room channel, which is what usually happens. You can just tag their comment with a notepad emoji, and this will actually add that very same sentence into your service disruption report. And what you get at the very end is a very well-formatted service disruption report that you just need to review and then pass as is. So it's really a huge time saver. So I've talked about how SPY actually helps us to reduce context switching. I've talked about how it prevents us from on-call fatigue, and how it actually saves us time by just doing everything from the war room. But more than that, it actually helps us to reduce the impact and duration of incident. Just because the IMOC and all the other responders can just focus on the incident and not waste time switching context or doing something else. Good. So now that I've shown you how SPY helps with IMOCs, how does it help with developers in general, right? What does it do for them? And this section is going to be pretty short, because developers usually learn commands by seeing others execute them. So if you go in Slack, you will see all day people using SPY for different reasons. And that's how you usually pick up what commands to use. And this actually fastens developers' onboarding. And we have also some SPY commands that help them just like hit the ground running. So let's say I'm new at Shopify. I can just add myself as a collaborator to teams by just typing in this SPY GitHub add user, and then my GitHub handle, and then I just type in the team. I don't need to reach out to whoever is the admin of that repo. I can just do that myself. And this is a huge time saver because you don't need to bug other people to add you in. You can actually do it yourself. And if you have like some restricted repos, you can also like add some authentication. What am I saying? Authentication step here. So let's say now I have a new Shiny project and I want to set up continuous integration for this. I can just add Circle CI with SPY Circle CI add and then the name of my project. And then similarly, if I want to set up build kite, I can do so with SPY as well. And the other thing that's actually helpful, as I said before, we deploy Shopify more than 40 times a day, and we have like more than 200 changes that go in production within the same day. So one of the things that's actually useful for developers is this shipit command. Shipit is our internal tool that we use for deployment. And then if you are a developer and you're just rolling a very sensitive change, you can actually log the deployment train so that you actually isolate your deploy from other changes. And this can be done with SPY shipit lock, the stack that you want to lock, and then a brief message to explain why you're doing this. And so the other useful thing to know here is when you're deploying your code, SPY will actually reach out to you and let you know when your code is being deployed to production. So all our deployments are automated. A bot actually puts together all the changes and actually ships them on your behalf. So when it's time for your commit to go out, SPY will actually reach out to you, send you a direct message, and let you know that your command is actually being deployed. It lets you know what channel to look into and what dashboard to actually keep your eyes on. And then once the deploy has completed, it will actually remind you to check if all the changes are working correctly. And if there is anything that's broken, then it actually recommends you to page the IMOC. So all the developers get these messages when it's time to get them. Good. So I've talked about a bunch of commands. Yeah, pretty handy, given what happened yesterday. So I've talked about a bunch of commands, and it's really easy to just be dependent on them and even forget how to use all the other things. And so the question that you might have at this point is, OK, what if Slack is down? What do you guys do? Do you still work as usual? Yes, we do. So if Slack is down, SPY has actually a Slack-free interactive session that you can always use for that. And the other thing that I usually do is that we use Campfire when Slack is down. But the other thing that can happen is that the data center in which SPY is actually deployed can also be down. And what we do in that case is that we have SPY deployed in an active-passive mode. So if the data center where it's deployed actually has issues, we'll actually activate the other SPY that was passive. And that's how we usually deal with resiliency here. So what have we learned from all of this? What are the benefits that we have observed? Well, we've seen definitely increased sharing and focus. Everybody has the very first reaction of going into a channel and actually trying to help out with everyone. And then you get to know what's happening and what context everybody's having in that way. We've seen a shortened feedback loop. So for instance, with the actions-related communication, you can just see what was the result of the action right from the channel, right from Slack. The other thing is that it has hugely eliminated manual toil. So for instance, just for service disruption report, we used to do a lot of copy pasting just by going through the channel, but now SPI has automated all of that. We have also smoother incident handling just because SPI kind of like streamlines the process and gives you those reminders. So you don't really see the difference between one IMOC and the other because we have like this process that's in place now. And it has also allowed us to see faster onboarding experience, definitely with new developers that start at Shopify. But we have also learned that when you start with ChatOps, you have to build in security and make sure that you restrict some of the commands that are sensitive. And you also have to build in resiliency. So you have to be ready to have a plan B if Slack is down or if even your own chatbot is down. And then the other thing is that it's still essential to kind of like make sure that developers know what to do when there is like no SPI around at all. So you should still know how to use that PagerDuty UI, just in case of need. So just a quick summary. I've shown you some of the commands that we use for infrastructure, namely how failovers have become so simple that a child can do them. I've also talked about incident management and how SPI actually helps us reduce an incident impact and duration. And finally, I've touched upon developer onboarding and how it helps our developers hit the ground running. So by this point, I really hope that I have convinced you that ChatOps is just not for cute gifts, but that you can do way more than that. It can help you attain new levels of efficiency. And I hope that by this point, you have actually realized that chatbots can actually be very powerful machines and actually frightening ones sometimes. Thank you. Just to add a quick note, so if you want to learn about resiliency, if you want to learn more about resiliency at Shopify, there is a talk tomorrow by my colleague, Jake, so feel free to attend. It's really interesting. And now I'll take questions.
Hi. So SPI does everything. It's a Swiss Army tool kind of a tool. Does it have a team? Does it have a product manager? How do you make it not become this weird, unwieldy, unmanageable thing? Thank you.
Okay. So Tanya's question was on how we actually manage SPI. Do we have a team dedicated to that? And how do we actually make sure that it's all contained? We have an operational excellence team that takes care of the operational side of SPI. But we also have like other teams that will actually do their own, I would say, management of their SPI commands. So it's both of them. We have a team, and we also have like other people who actually work on their own commands.
Hi. So bot syntax seems, the command syntax seems to vary in complexity from command to command. Do you find this frustrates users at all? Do you find they have to like retype commands over and over sometimes to get things going? Like, how do you deal with that?
So we usually try to keep the same kind of syntax. So, but usually when you type in a command and it doesn't go through, SPI will actually suggest you how to autocorrect your command. So if you just type in, I don't know, SPI pod failover instead of SPI failover pod, it will actually give you the right suggestion on how to type in that command.
Hello.
Hi.
How are you handling the Slack webhook as it comes into your organization and has to interface with all of your different applications?
How do we handle the Slack webhooks?
Yep.
So as I've said before, Spy is built on top of LISA, and LISA usually actually has an adapter for Slack.
Okay.
So that's how the handling is done. But for actually handling all the load balancing and the requests, we actually set up 10 instances of Spy. So that's how we do all the request balancing and stuff.
Cool. Thank you.
No worries.
How do you manage audit trail from your infrastructure side when everything is done by Spy, basically?
How do we manage the infrastructure trail?
No, how do you manage audit trail so you know who did what when, since everything basically is done by Spy from the infrastructure point of view?
Yeah.
I mean.
So two things. First of all, we keep a trail log within the Slack app itself because everything is in there. And then the second thing, for those sensitive operations, for instance, the failover, you'll actually need to authenticate yourself as the user. So we'll get who did actually that command. So before performing failover, I'm going to authenticate myself as Daniella, and then what will be printed out is Daniella is performing a failover. So that's how we can actually keep track of who did what for the infrastructure-sensitive commands.
Hi. Is there ever a scenario where you need at least two people to verify something, either because of regulatory reasons or because of things like SOC 2 that you would have told your clients that you're at least going to have two sets of people looking at any changes?
You mean two people looking at what kind of changes?
So at the moment, some of the examples you gave is like Daniela just logged in and does a pod failover, but what if Daniela was not the person who was experienced at doing that, and she hasn't done that for the last, let's say, 6 months, and something has changed behind the scenes? So you would need, in certain scenarios, like somebody else to also validate your changes, right? Like normally when you do a code, you'll get your peer to review it. But
yeah.
When you're doing production changes, nobody is reviewing it other than a bot who's just verifying that you are who you are.
So for the production changes themselves, the one that require pull requests, those are peer reviewed before going out. Now for changes that are related to production, so for instance, let's say failovers, if I'm performing a failover and I don't really know what I'm doing, I should know though, because Spy will actually tell you, are you sure you know what you're doing? What this will do is that it will send a message to a failovers channel. So everybody in the failovers channel will actually know what you're up to. And if you screw up something or something doesn't go well, you'll be held accountable, and then you will also have other people looking after what you're doing.
Okay, thank you.
No problem.
For the more privileged commands where you have to do an additional authentication, can you explain more how that was implemented and how it looks architecturally?
So we basically have something called a pseudo command or pseudo component, and what this will do is that it uses Google authentication underneath, which is what we use mostly for all of those. And we also have other commands that are backed up by Okta. So we use those two mainly when it's time to authenticate those commands.
Two questions. First is, does Spy work only with Slack? Is it hard or easy to integrate with something else, some other chat product, which we have our own?
You mean...
Does it have an interface for something else to be connected to Slack, instead of Slack?
Instead of Slack?
Yes.
So we do have, if I remember, I believe that Spy is also connected to Campfire, which is our backup chat app thing. But otherwise, I don't know if you meant if somebody else was to take Spy, if it's actually easy to plug it in some other chat app.
If your own chat app, chat product, is it hard or easy to, or is there basically a possibility to integrate Spy with that?
Yeah, there is definitely a possibility to integrate it with some other chat apps, because LISA itself, which is the framework that we built Spy upon, has many adapters for many other chat apps. So as long as that adapter part changes, the Spy side doesn't change that much.
Okay, and second question, from the scratch, if I was to start with Spy, how long is the process to get it set up? Is it tedious? Is it a short process, a long process?
To actually get the entire Spy commands set up.
Yes.
So it took a lot of time and then iterations. This is what we've came up after many years. But if you want to get started, I would say one way to do it would be to start with some very simple third-party integrations. And then once you're comfortable and everybody has been converted, you can then start with the chatbot, maybe start with some of the command, query commands or things that you usually do on a regular basis and automate those. So those would be a good start.
Yeah, thanks.
No problem.
Hi.
Hello.
So I'm going to assume that your examples are like real cases, right?
Yeah.
So you
I
had
tried to hide
you had like
sensitive
an
data.
example there, which was like a spy incident stop. So the question is like, how do you handle more than one incident at a time?
Oh, that's a very good question. So when there's more than one incident, what Spy will actually do is it will create like multiple war rooms, and it will like follow like keep the related data into a Redis like system, and so all the information that's related to one war room will be like isolated from the other war rooms.
So it means like if I type that command in the main room, it won't work.
Sorry?
If I type like that command in the main room, it will not work.
No, you have to type that command into the room where you actually want it to end. So if it's war room 1, you have to type it in war room 1. If it's war room 2, you have to type it in war room 2.
Thank you.
No problem.
All right. Thank you so much, Daniella.